How did Celsius define his scale?
He took the temperature water freezes at and said that's 0. And then he took the temperature it boils at and says that's 100. And he figured 100 was a good amount of demarcations to make in between the two.
Right?
Yeah?
Except that's not what he did.
Really?
Celsius never devised nor used the scale that now bears his name.
Are you kidding me?
No, Michael, I'm not. This is the Swedish town of Uppsala, located 70 kilometers north of Stockholm. So this is the house where Celsius lived. In 1741, he was professor of astronomy at Uppsala University. And this is the first ever Celsius thermometer. Or is it?
It says the first scale of Anders Celsius.
Added on to an old Delisle thermometer.
So we have Delisle's scale on the left-hand side,
Yeah.
and Celsius's new scale on the right.
Yeah.
These few markings show that Celsius came up with the idea of separating the freezing and boiling points of water by 100 degrees. He made his first observations with the scale on Christmas Day, 1741. But have you noticed something strange about this scale? I mean, 50 is marked in the middle, but the numbers increase down towards the bulb of the thermometer. So Celsius had his scale upside down. He set 0 degrees at the boiling point of water and 100 at the freezing point. Why would he do this? Well, for one thing, Celsius was just following the convention of the other scale on the thermometer. Delisle's scale also had 0 degrees for the boiling point of water, increasing down to 150 for his freezing point. And a likely reason both of them used upside-down scales is because they avoid negative numbers. In Sweden, it gets much colder than freezing, but never warmer than boiling water. So you don't have to worry about pesky minus signs, and this helps avoid logbook errors.
I think it would be really weird if you had water boiling at 0 degrees and freezing at 100. Wouldn't that be strange?
Although it might seem strange today, there is no objectively good reason for preferring an ascending scale over a descending one for measuring degrees of something, like hot or cold. In fact, when Celsius died of tuberculosis in 1744, he was still using this inverted scale. So who reversed it? Who do we have to thank for the modern Celsius temperature scale? Well, in 1745, just a year after Celsius's death, a new column appears in the Uppsala temperature record, using the modern scale, and at the top it's got the heading Ekström. Now, Ekström was the instrument maker at Uppsala. In 1747, another column is added with the heading Strömer, who was Celsius's successor as professor of astronomy. Again, it's got the same modern scale. But it's another professor at Uppsala who claims that he reversed the scale. That's the famous biologist Carl Linnaeus. He says he reversed the scale when he ordered a thermometer from Ekström for his greenhouse. Whoever it was, we know that by 1745 there was an operational thermometer at Uppsala University with a scale that we now all know as the Celsius temperature scale. Except this was not the first such thermometer ever created. In 1743, the year before Celsius died, a French scientist working independently in Lyon created a thermometer with 0 degrees at the freezing point of water and 100 at the boiling point. His name was Jean-Pierre Christin. So why isn't it called a degree Christin instead of a degree Celsius? Well, for a long time, this temperature scale wasn't referred to using either of their names, and instead it was just called the centigrade scale, meaning 100 steps. The problem with this was centigrade has other meanings in French, Spanish, and Italian, where a grade specifically refers to 1/100th of a right angle. So to eliminate this confusion, the International Bureau of Weights and Measures in 1948 decided to rename the centigrade scale after a scientist, bringing it into alignment with other temperature scales like Kelvin and Fahrenheit. They chose Celsius, possibly due to a popular 1800s German chemistry textbook by a guy named Berzelius. In it, Berzelius identified Celsius as the first to devise a temperature scale with 0 at water's freezing point and 100 at its boiling point, propagating the myth that Celsius created this scale. So, is Celsius undeserving of having his name immortalized on weather maps around the world? Well, no. I mean, making 2 marks and deciding on a number of degrees in between them, that is the easy part, which others could, and as history shows, did do. But what Celsius did was he established which physical processes could reliably produce a fixed temperature. At the time when he was working, there were some 30 different temperature scales in use. Some thermometers had 18 different scales on them, some more reliable than others. For fixed reference points, one scale used the deepest cellar of the Paris Observatory. Others used the melting temperature of butter, the internal temperatures of certain animals, or the hottest day in summer in Italy, Syria, or Senegal. These dubious scales, combined with inconsistent thermometer construction, made recording accurate temperatures nearly impossible, not to mention sharing those temperatures with other scientists elsewhere. Celsius solved this problem in a number of ways. He demonstrated that melting snow maintains a fixed temperature regardless of latitude or ambient pressure. He also determined the precise relationship between boiling point of water and the ambient pressure, so that thermometers could be calibrated under any conditions. He made it possible to establish a universal, reliable system of temperature measurement. And this is why Celsius's name is a unit of temperature, even though the scale itself was not created by him. And in fact, today, the Celsius scale is no longer defined by either of water's phase transition points. Instead, it is based off the Kelvin scale, and that scale is defined by setting the triple point of water, where solid, liquid, and gas all exist in equilibrium, at exactly 273.16 Kelvin. This fixes the size of a degree Kelvin, which is exactly the same as the size of a degree Celsius. The 0 point of the Celsius scale is set at 273.15 Kelvin. Now, what all this means is that today pure water boils at 99.974 degrees Celsius and freezes at negative 0.0001 Celsius. This precision in a nearly universal system of temperature measurement is thanks to a huge number of scientists. So the C after the degree symbol stands not only for Celsius or Kristen or Carl Linnaeus, but for the community of scientists whose work over centuries made a scale so robust that we take it for granted.